Welcome. I am Amy Brenner, Director of the CAS Institute, also known as ICAS. Recently, ICAS added a new book to its curriculum, Data Visualization by Duke professor Kieran Healy. As a result, Princeton University Press is offering ICAS members and friends a 30% discount on the book. For information on how to obtain that discount, or to find out more about the CSPA, please visit our website, thecasinstitute.org. Recently, CAS research actuary Brian Fannin interviewed Professor Healy about his book. Here is that interview. Take it away, Brian.
So starting off, you've written this book about data visualization, which I think has appealed to people across the data science, data analytics spectrum, but you teach sociology. Now, I get it that there are quantitative elements in that, but it's not something that people will immediately assume is associated with data. So which came first, data or sociology?
Well, sociology is a very methodologically heterogeneous discipline, and people work with data and methods of all kinds. And sure, it ranges from, ethnographic data, where people are spending a lot of time in a field site, to interviews and textual material, archives, but then right the way through to much more quantitative stuff like surveys and official statistics, even experiments and so on. So there's a lot of quantitative data, and there's almost always data in social. And so for me, the sociology came first because that's what I studied. But one thing to kind of bear in mind is that what maybe one of the impetuses was that precisely because there's so much methodological variation, people work in different styles. Well, then there's also this kind of demand to be able to communicate effectively if you are working with sort of what you would think of as conventionally quantitative data. So you want to be able, and so data visualization is a great tool for that.
Very cool. So the sociology started, and then if I heard you properly, the visualization was a means to improve the communication of what you were working on.
Well, as I say, for me personally, that's just a feature. It's always been a feature of the data analysis that I've been doing, and it's also that embedded in the field. I mean, many of the early pioneers in visualization were connected with sociology and social policy in various ways, all the way back to Du Bois or the people working at Hull House in Chicago in the 19th century. They're drawing maps, they're drawing graphs,
Mm-hmm.
So it's not as if this was sort of unusual in the field.
Okay.
And
so it's a very natural fit.
Yeah, very much so.
Okay. The book itself, it should probably mention for posterity's sake, you've written a book about data visualization, which is fantastic. I've got a copy. One of the unique things about this is if you compare this to like Tufte or some of the others, which focus on design principles and cognition, all of which are important, yours has, I think, more balance towards a practical guide. That means that you have to settle on a specific library or platform for implementation. Can you talk about what led you to R and ggplot instead of some other tool?
Sure. Well, I suppose there's a pragmatic version of the answer, and then a kind of more worked out or reasoned version. And the pragmatic version is just that this was the toolkit that I was using, and so it was easiest to start with that. But that just leads to the natural question, well, why were you using this toolkit to begin with?
Mm-hmm.
And that answer, I think there are several dimensions. One is that R in general and ggplot in particular is an open and free platform. It's widely available at no cost to everybody, and so that's important. I feel like there's in the world of data communication and scholarly work generally, I think it's important to rest and to build our foundations on things that are easily shareable in that way. So R is a fantastic project for that, and I've been using it for many years as a result. A second criterion was reproducibility, that is being able to revisit work and redo it in a straightforward way. And so that means that you're going to be coding. And so there are other tools that are menu driven or other things and that you can learn to use, and they're very powerful. But as a working social scientist and many other sorts of data scientists and people in the sciences generally, you want to be be able to go back and revisit your work and have the control over it that being able to code gives you. And then ggplot specifically implements this grammar of graphics, which is to say that it has a model of what a data visualization is that's derived from this work by Leland Wilkinson about 15 or 20 years ago now. And the nice thing about that grammar is that it is a pretty clear way of thinking about what's involved in the process of taking some numbers and turning them into a visual representation that accurately reflects what those numbers mean. And so I think that a lot of the alternative software tools, now there are many good ones, and I'm not really, I'm pretty, as I say, I'm pretty pragmatic in terms of tool selection. But one of the things I would say is that sort of many tools that I've taught with before, or that I see other people using, is that they sometimes they work at the wrong level of abstraction. And so there's either it's too high, where you're just thinking in terms of kind of how, in the sense of how do I make a bar chart or a line graph, which buttons do I push to get those, which quickly becomes kind of limiting for users, or it's too low. And this is true of many sort of coding tools where you have a million options to tweak every aspect of the plot, but everything is treated kind of in the same way, that is as a single sequence of adjustments that you make to your plot so that a change to the scales, say, is conceptually the same as a change to the choice of font. And that can be very confusing for people. And so ggplot has this flow of action where the grammar takes you from the data to a set of mappings for a kind of plot, and then on to adjustments to scales or guides and thematic elements. And it has, in addition, this layered quality where you can build up the components of plots a layer at a time. And so once people get a handle on that, it's like having some sort of X-ray vision where you can look at graphs and you can see what their logical structure is, why it is that they're working, and you can separate all of these pieces and layers and the order that they're done in, and then you can think of the commands or functions that you'd need in order to make it yourself. And so ggplot really fits that, hits that sweet spot very, very nicely, I think.
Sweet spot. You took the words right out of my mouth. I was about to say that it offers, in my experience, sort of the best of all worlds in terms of having the ability to tweak the minutia, but not the requirement to do so.
Yes, exactly. You've got, and it also sort of fairly cleanly separates, as I say, it has this model of, you've got your core, here's what's going to be represented in my data, here's the kind of plot or geom that I want, and then subsequent things which you may or may not want to touch, and you don't have to, but which then you can adjust in a clearly separate way. And that really helps people understand, what it is that they're doing, so that it's not just one huge undifferentiated blob of kind of options that you have to hunt through if you want to set something.
Whenever you talk about this, and I hope people will forgive me for kind of calling out one of a very popular library. Have you ever done much work with D3?
I have a bit, a little bit, but I wouldn't say that I was fluent in it.
It's interesting because my experiences with it feels as though it hits some of those boxes of having a great deal of power, but just things like scale transformations. Well, okay, let's sit down and read the paragraph about how to do that. And
D3 is a sort of a slightly lower level of abstraction than ggplot. It's more like, in our term, it's more like the grid library that underpins ggplot.
Exactly.
And so it has more primitive, in the sense of fundamental or low level tools that you have to work with directly. And so, I mean, this is a common problem in software design, that any toolkit has to make these trade-offs, because when your abstraction level is high, then easy things are very easy, but harder things are awkward, and really difficult things are impossible. Whereas if you're at a very low level, then easy things are really hard, actually, because you have to be working at this level of draw a line here, rather than just say draw me a bar chart. And then very hard things are possible, but it's awkward. And so you want to sort of have some kind of trade-off where you can get up and running fairly quickly, but then difficult things that are out of the reach of something like Excel, for example, are still possible because of the language that you're working with.
Sure, absolutely. And I've been very, very happy with ggplot. I tend not to use much of anything else. Talk a little bit about interactive data visualization. Very often these are static images, like in a textbook, or I mean, I suppose people still read magazines, but more and more they're getting them online. And one of the big questions that I often get is, how do I feel about interactivity, wherein the user is manipulating the visualization? What's your take on that?
I think that yeah, there's a couple of different issues that come up. So one is that we can make a sort of rough distinction between two kinds of interactive visualization. One is where you can sort of poke around, for example, just at a minimum, highlighting the points or values or clicking on stuff to see what the specific data point is or observation, in sort of JavaScript libraries that you can look at in a browser. So Plotly does this pretty well, and it interfaces quite well with ggplot. And that kind of stuff can get more and more sophisticated, like right up to things like the work that sort of Dai Cook and her collaborators did in the 90s and into the 2000s, where you're looking at sort of loads and loads and loads of high dimensional data, and you want kind of grand tours, they were calling them, or projection pursuits, where you really have like you're not just looking at a single scatter plot, but you're sort of moving through many hundreds or even thousands of variables and trying to see what the patterns are. So there's clearly a need for that. Some kinds of data demand that kind of interactivity because it's so it's so complicated.
Mm-hmm.
Then there are also kind of more on Rails versions where you're sort of led as the user through a kind of semi-interactive demo almost, or that where things are highlighted for you.
Mm-hmm.
And so the New York Times' work with the Upshot and stuff like that, they do really great work like that. Or the Gapminder animations,
Yep.
where you're just seeing, and so that stuff can be very effective. And then, but I think the challenge of it is that the more dimensions in the more aspects of that you introduce into your visualization, literally moving parts, often, then sort of the more challenging the interpretation becomes for the user and for the viewer, and sort of decoding all of that. And so sometimes the story is very direct, like with some of the Gapminder animations, and you can really use something like animation or interactivity to deliver a punchy message. At other times, it can sort of obscure. It can just be like, wow, that looks really impressive, but I'm not really quite sure what to take from it. So those are the two ends of it. Like when it can be useful to be able to highlight specific points. Like I want to look at this county in the United States. I want to look at this year. So that can really be great. Sometimes the challenge for social science data and others too is that if you're looking at sort of raw data at some level, sometimes, by definition, interactive plots include all of the data in the plot. Like behind it, you're looking up to highlight a table, and sometimes you can't do that for the kinds of data that people are working with. If it's summary data, you can, but sometimes if it's individual level data, you're not able to show because it's proprietary or it's confidential or what have you. And so that can be a challenge for interactive work too.
Okay. There are at least two things that I kind of want to pick up on there, and I'm trying to think which one I want to go for. Be able to do this one, and then I'll come back to another thought that I have. You hit on something at the end there in talking about high dimensional data. I don't know what your experience has been, but even beyond 2 dimensions, I start to struggle because we're looking at a 2-dimensional image, and we're in a world where big data is no longer even a buzzword. It's just a kind of a fact of life. It's inescapable. So specifically, well, you can say big data, which is either wide or tall. What are some of the strategies that we have to employ to be able to make sense of that visually?
Well, I mean, the thing is, right, that this is why we have statistical models and other methods for, one of the things I always emphasize when I'm teaching this stuff is that, data visualization is just one tool that we have in this big toolbox we have as social scientists or statisticians or what have you. And often the challenge is to sort of, you're looking for structure in your data. Visualization is a tremendous boon when it comes to kind of finding that, but sometimes, or very often, there's so much data or the structure is tricky. There's a reason we have this whole panoply of statistical models, methods for data. They're all essentially methods for data reduction because we have too much. Right. And then you can visualize the results of them. And so data visualization has to be thought of as working sort of in conjunction with these other methods that we have, and that they're not substitutes for one another. And so sometimes you get this kind of situation where often data visualization is motivated to people by showing you things that you can see in a scatter plot or in a graph that would not be immediately obvious, or that you if you just looked at numerical summaries. And so that's certainly true. But the same is also true in reverse, right? That there's a reason, as I say, that we have the summary statistics to cut through a cloud of points, so that we can see whether the structure we imagine or we think we're looking at is actually there. So the sort of judicious combination of all these various methods for data reduction and analysis need to be thought of as being, part of a toolkit that extends well beyond just being able to draw a graph.
Cool. I think that takes me to the other question that I've had in one of your earlier responses. When we talk about specifically interactivity, and you had said that you can kind of go beyond the usefulness of the interactivity to get to the place where the complexity overwhelms the user. Generally speaking, are there any of those, I call them yellow flags, whenever I'm developing a visual, and you'll get that tunnel vision, and you just really want to represent it graphically. One of my yellow flags is if I have a lot of white space, then I need to rethink whether this is the best means to do this. But in terms of interactivity or large data sets or highly complex data sets, are there other kind of yellow flags that will indicate to the designer maybe visualization is not the right approach in this case?
Yeah, or maybe visualization is not the right approach, or maybe you need to think a little more about what it is that you want to reserve for the visualization in order to show. Yeah, I mean, those teaching that sort of, or getting a feel for those sort of judgment calls is definitely, the most substantively useful thing you can be aware of or try to be reaching for as you practice things. So, for example, yeah, like. And these are all just kind of rules of thumb, right?
Sure.
Heuristics rather than
exactly. Yeah.
Ironclad rules.
Sometimes people get pulled over by the visualization.
Yeah. Sometimes people get a little fixated on particular things. They say, "Oh, you should never do this." Well, but like a yellow flag. Like, well, can you not see any data on your graph? Is one at one level. Like, there's too much white space. There's all of this, and it's not clear. If you have your data, is there too much of it? Is the opposite one. So, for example, and sometimes you see the classic, you see this in social science a lot, right? With network data, you see the classic network hairball graph. It's often called like something the cat threw up, and it's like, well, that looks like science, man, but
right,
but also who knows what it means, because so network visualization is extremely hard, but clearly. Sometimes the rhetorical function of those graphs seems to be look at how much data I have. It must be really complicated. Right. But that's not helpful. In everyday graphing, often I find saying to myself or to students, if you find yourself having a lot of scales being drawn, by which I mean sort of color and shape and size, along with like often you want to try and minimize the work the reader has to do in combining, objects are coded by color and by shape, say, or color and size. And so you have to, the reader has to look at sort of the x-axis, the y-axis, the color scale, the size scale. Well, then you're just putting a lot of load on cognitively on the user at that point. And so maybe you want to think about how to, break those up. That's one of the ways that small multiples, can I take one of my scales, essentially my legends, like picking out some categorical variable and break it up into a series of panels instead, right? That would be a very common kind of, like if you have a graph where your eye is constantly going back and forth between the legends and the data, well, then maybe that's a sign that you could simplify things a little bit, for instance.
Yeah, so the user is doing a lot of decoding when you could anticipate.
Yeah, and of course, this is going to be something that varies a lot. When you make a graph, always you're thinking of, or you should be thinking of, who is this for? What is the purpose of this graphic, and what audience am I intending it? And so, for some sorts of graphs, the audience is very used to looking at data of a particular kind, or a representation of a particular sort. So that's fine. For other sorts of graphics, something is perhaps to an expert audience as straightforward as a log scale might be confusing or seem manipulative in some strange way, and so you have to think about kind of, and again, this is something that the grammar of graphics ggplot tries to implement, I think it implicitly sort of emphasizes, which is that you're taking these numbers, you're encoding them as visual representations, and then they have to get decoded again by the viewer, like who has to sort of in some sense mentally reconstitute, like, well, what is this table saying of numbers that it's showing me? And so you can't forget that there's that process, not just of getting it into the graphic, because the tools are powerful, but also the viewer has to be able to get them back out. And a lot of that depends not just on the decisions that you make as the designer, but then also your understanding of who those viewers are and what they're expecting.
Absolutely. You mentioned log scale as being one where people who are numerate or have statistical experience, we understand that. 2020 was the year that the log scale suddenly appears a lot more frequently than I had expected. And of course, within the context of COVID-19, because of whatever metric we're looking at. So suddenly a log scale is in the vernacular and people are talking about this. And data visualization is critical to communicating some of the salient numbers about the global pandemic. It's difficult to say this now, but we're only in August 2020. But looking back over the past 7 months or so, are there any lessons learned about either an audience's ability to adapt and learn, or maybe some visualization fails that
I think we saw a lot of learning on both sides, on both in terms of the people who were designing the graphics and on the part of audiences and what they got used to seeing and how they came to understand it, and it was partly as a result of the as the direction of the pandemic sort of took shape, the graphical needs also changed as time went by. And so I think one of the focuses of this that we saw, for example, John Byrne Murdoch, right, at the Financial Times early on, was doing really, really good work showing comparative graphs in the early days of the pandemic. And at the beginning, he was showing these, which is the only data that we had, were just kind of counts of the rate at which it was expanding, the case counts of across these different countries. And so to begin with, you have these different countries of wildly different size, and then different sort of numbers as a result. But so he started to get some flack about, well, shouldn't you be setting these per capita, right? That's something that people know. You should be standardizing these somehow. Right. And the answer in the early days, it was like, well, yeah, but the population of China or the United States actually isn't changing over the course of the time that we're observing. So what we really care about is how fast it's growing. And
within
that's
a country.
Within a country, yeah. And so at that point it did sort of matter. And then later it was like, well, yes, if you're looking at sort of excess mortality or rates over a period of months or a year, well then something like per capita scales can matter a lot then, or depending on the kind of comparison you're doing. And Murdoch himself and his team at the Financial Times and other places were adapting along these lines. And the log scale was also a case where where people were doing that. And I realized how following this along, I realized how uncommon log scales are in everyday life. For the only two widely used log scales that people kind of see most of the time are the Richter scale for earthquakes, and maybe the pH scale, but the Richter scale is kind of the only thing that's in the news, and so that meant then that a lot of people were confused, or they would see these. I was just teaching some first years, some freshmen here just last week, and I was using the example of these log scales to transform data, and there was definitely this sense, they're like, well, isn't that cheating, stretching it out like that, and you try to say, well, no, we were looking at income data, which is a log linear distribution, they're very skewed, and it's like, well, no, that means you'll be able to see the full distribution, and otherwise you'd miss, and yeah, you really need to, I think COVID really made clear, what's at stake in the effective communication of results or trends, and that also, ultimately these visualization tools that we have are like any tools for data analysis. They're embedded in a community of practice of people who are trying to do good work, hopefully, and they can't make those people honest, and they're not magic. So what you want is to have kind of people who use these tools who know what they're doing, and who can sort of explain what they're doing to other people, and you need that sort of collective level of trust, that well, here are the choices I'm making. I'm being as clear as I can about them, and then here's what these graphs can and can't show, rather than, moving over to the side of like, here's this flashy graphic that that may make an impression on people, but that isn't honest. And the environment that we're in now, for COVID and for many other things, is such that people know, like the regular broader public audience is kind of aware that graphics can be used to mislead them. And so that puts a burden on an onus on people working to produce these things to be as clear as they can, and just be steady in their own application of standards, knowing that these tools, it's easy for people to be suspicious for good reason, right, to have things be misread. As I say, these are just tools that can make your work better, but they can't make people honest. They can't force, they're not sort of magic things that just by using this piece of software, that means that your work is automatically more credible. That's not how it works. These are just people doing scientific work, with amongst a community of peers, and trying to abide by kind of the standards of their field.
I've certainly discovered that as much as I enjoy visualization and as useful as I find it, it doesn't make my work or my conclusions any smarter, which
right.
I was disappointed to learn that it
right.
still needs to put in the work, and then the visualization also I need to put in a little bit of extra to make sure that adheres to standards of clarity and communication.
Right, exactly.
So as you know, we have I think a lot of people who are seeing visuals for the first time, and certainly with the availability of tools like ggplot or D3 or Plotly or so forth. My profession, my field, actuarial science, we're now emerging from sort of the spreadsheets, and there is an appetite for visualizations as a field in itself, similar to statistics and modeling. So we've got a lot of newcomers into this discipline. What would you say to them? Like, what do you wish that you knew when you were first starting to approach visualization?
Well, let's see. I really emphasize that visualization is one tool that you have to work with, as we've just been talking about, to understand data. And so we need to get clarity on things in our data. We want to understand what's there. And there are so many examples where just very elementary visualization is tremendously helpful for understanding what's happening. But then by the same token, as I said earlier, there's a reason we have these other methods as well, right? And because finding structure in your data is hard, and it's especially hard when we're the sort of human beings or the sort of creatures that are very good at finding structure even when it isn't there.
Right.
And so, as I think, was it Feynman or somebody, Richard Feynman, remarked somewhere, that you're the easiest person to fool, in part as you're working with your own data, because you want to find interesting things in there. And so starting out, it's the tool is useful for revealing structure, but then you're just this fallible person, and you have to kind of be on your guard against yourself, and be honest with yourself and with the people that you're showing your work to. So that's the first thing I wish I'd known. And then the second thing, to be honest, is I'd wish I'd known how to get from seeing examples of really well-crafted visualizations and understanding why they were good to actually being able to produce versions of them myself. And which is really kind of why I wrote the book, because so many introductions to data visualization are beautiful catalogs of undoubtedly superb work and discussions of sort of why it's so good perceptually and so on, but with no hints on how to actually do it. And so many introductions to software end up being treated by users as kind of incantations to mechanically copy and paste, or as technical manuals that don't have kind of fleshed out rationales or motivations. So really kind of wanting to emphasize that craft element where you know what you're doing and you know why you're doing it, and you're in command of the tools that will actually allow you to produce stuff, is very satisfying for people as they're learning it. One of the really nice things about learning something like ggplot, even as a gateway into R and other tools, is that sure, like even Minard with only produced one of those kinds of graphs in his entire life, the Napoleon's march and retreat from Moscow. But even just with a little bit of practice, you can very quickly get to the point where you can produce really quality stuff that would be sort of out of reach. So knowing just how to do that, and in a kind of self-reflective or a self-conscious way, is terrific. That's what I missed at the beginning. I spent a lot of time, when I was starting out, looking at finished products, and it was like going to a fine art gallery and just thinking, how could I possibly, how could I possibly produce anything remotely as good as this with the, where can I start? And so we have these tools now that it won't make you Leonardo, but
sure.
you can do so much with them once you've got the picture in your mind about how to proceed.
I think that's a great metaphor. This idea of walking through an art gallery and like reading someone like Edward Tufte, and everyone should, but he's not going to give you tips on how to reproduce them. So you go through the Louvre, and then at the end of it, okay, so here's a blank canvas, off you go,
right?
Kind of a thing.
And it's the draw the rest of the owl,
Right.
and is the polite way of there's an extra word in there, and that did, but yes, exactly that, and so just having that connection and understanding that the technical tools that we have now, because of all of this tremendous work that people have done for free, this was one of the great things about our community in general, is like these tools are freely available, they're improving all the time, and they put in our hands the ability to to start down this road of being able to produce really high quality stuff very, very quickly. It's terrific.
Cool. Well, one final question. What color is the dress? It's black and blue, isn't it?
Well, you tell me what color it is, and I'll tell you what the average brightness of the room that you're in is.
Okay. Very good. With that, I'm going to thank you for your time. Your book, I'm going to hold it up. Data visualization. Kieran Healy, thank you so much. We appreciate it.
Thanks so much, Brian. That was great.